Hey everyone, welcome back to my STL playlist, and today we are going to see a very interesting use case of using set along with struct, and we will see why. This is basically a debugging session, and we will see why a certain error occurs. So yeah, let's start. So first of all, let's read the problem statement. The problem statement says that given a list of students, find the number of unique students. Okay. So first of all, let's see what the student looks like. So my student would look like, it would have an ID, it would have a first name, and it would have a last name. Okay. And let's see the list of students. So I have created this vector students and I have initialized it. So let's see this. So the students vector looks like this. It has multiple students, like 1 2 3 4 5 students, and 3 of them are, like you can see this line number 17, 19 and 20, they are all same student. So there are, in all there are 3 unique students. This the one with ID1, the one with ID2, and the one with ID3. Okay. So let's try to code this. The first thing which comes to my mind is, why not we just create a set and then insert all the elements of this students vector in the set, and then just print the size of it. Since set contains only unique elements, we will have the number of unique students, right? So yes, let's start to code. So set of student st, let's iterate over all the students and insert the students, right? Now let's print the size of the set. Okay, let's try to compile this. Okay, so something went wrong. Let's try to see what. Let me first move to the top, and then we'll see. So these are all, let's skim through this and move to this part. So it says that error, no match for operator less than, and you return x less than y. So it cannot find this operator less than. So why do we need this? I mean, think about it. Why we need this less than operator? So pause the video and think about it. And yeah, so I hope you guys have thought about it, and I would like to show you with a picture how an insertion works in set, which is actually very important before we start to debug that issue. Okay. So let's say this is my current set, and as we all know, set is arranged as a balanced binary search tree in C++. So let's say another element, let's say 49 comes, and we have to insert 49 in this set. Okay. So what happens is that when 49 comes, it will first compare, is 49 greater than 40 or is it less than 40? If it's greater than 40, we'll move to the right. If it's less than 40, we'll move to the left. So we know that 49 is greater than 40. So we move to the right side. We come here. We see that is 49 greater than 50 or is it less than 50? So 49 is less than 50. So we move to the left. Again, we do the same thing. Is 49 greater than 45 or is it less than 45? So 49 is greater than 45. So we move to the right, and since there are no elements here, we will attach 49 here. So why we do this? We do this because we want the whole structure to be balanced, and we want searching to be in log n. So we want to maintain this constraint of at each time. So yeah, this is the reason we have this insertion algorithm. But one thing you must notice is that what do we do, like to go from left to right or right to left? What do we do? We need to compare, right? We need to compare 49 with 40. So to compare, we need to have some kind of operators defined. So for integers, it is actually well defined in C++ itself that 49 is greater than 50. But since we have a struct over here, we need to tell C++, okay, hey, we need to tell it that this student 1 is lesser than this student 2. Okay. So yeah, let's go back to the code and make the changes. So yes, let's try to implement the bool operator less than here. So const student and s1 const, and we are just going to say that if id is less than s1.id, then return true, else return false. Okay, so here we have defined this less than operator, and now our set has one way to compare the two objects. Whenever a new object comes, it knows how to like compare both of them and move right or left. Okay, now let's compile this and see if it works. So reset it. I hope it does compile. Yes, it does. And let's print this. So as you can see that it printed 3, which is correct, which is the stereo size is 3, and we indeed have 3 unique elements, the one with id1, the one with id2, and the one with id3. So you must realize that the important part of this was not jumping from compilation error to like implementing this one. Like you should first know that why this compilation error occurs. So we saw that the compilation error happened because we had not defined this operator. So we should investigate that why having a less than operator is important in set. Okay, uh, in fact, if you do the same thing with map, you will face the same thing. You should also you have to define this less than operator for maps too. So yeah, I hope this was helpful to you people. Uh, please yeah, make sure you understand the whole concept, and let me know in the comments if you are having an issue. We'll try to resolve it. Thanks, have a nice day, bye.